we're fortunate to have Tony Robinson from Gale Associates, Senior Associate. Mr. Robinson is a Senior Associate with Gale Associates and Companies, Building Enclosure Design and Consulting Group, and Springs, Florida. He has 30 years of experience investigating, evaluating, and designing repairs to the building's enclosures and roofs, walls, windows, and waterproofing. As an associate, he manages the Florida Regional Office. He also manages projects through all phases of building enclosure consultation, including initial investigation through preparation of design documents and construction period services. He specializes in the peer review and the commissioning of exterior building enclosures, components, systems, assemblies. Commissioned projects include U.S. Green Building Council, the LEED Gold, Silver, and Platinum projects. Mr. Robinson is also an FAA certified remote pilot for the SUAS drones. Mr. Robinson has been flying drones recreationally and commercially for over 2 years and has been providing presentations on the use of drones for approximately 3 years. He is a member of the FLAPPA, the International Institute of Building Enclosure Consultants, and the Society of American Military Engineers. It's my pleasure to introduce to you Mr. Tony Robinson.
Thank you, Ron. Let me close this out. Good morning to everyone. Let's get this set up properly here. It's a pleasure to be with you this morning. I've had the pleasure of speaking with at FLAPPA a few other times, and I appreciate the opportunity to come back and share this presentation with you all this morning. As the presentation states, we're going to talk about how to improve the performance of your building. When we talk about the performance of it, we have a few, it's just that nothing's working right this morning, so I'll just do it this way. How's that? There are a few things we want to glean from this presentation, and one is we want to understand the building's role in energy consumption. We'll get into each one of these in detail as we go through the presentation. Then we'll discuss typical building components and control layers that occur on the building exterior. Review case studies. I have a couple of them that we share with you. Maybe if we have time, we'll do maybe another one, 3. And then learn techniques and technology that are available to measure your building's performance. And this presentation, as he alluded to, I specialize in building enclosure design and consulting. And so everything's going to be kind of related to the building envelope itself, the roofs, walls, windows, subgrade, waterproofing type things to improve the performance of your buildings. First of all, let's give you a little history on energy consumption. There's a conference that was held. The conference is COP26 is going to be held actually in Europe this year. It's an annual event that brings together governments from all over the world, and they talk about climate change and controlling managing issues related to emissions into the atmosphere and basically keeping the earth green. And keeping the earth from having that green heat island effect and all of the different things that happen with the energy, with the earth when we put all these emissions up into the atmosphere. So they get together and they talk about these. The first COP meeting was held in 1995. And like I said, it was the world leaders, and it's an annual thing. This marks the 26th gathering of this group of individuals. And back in the COP 21, they all agreed and came together and signed, which many of you might have heard was a Paris Agreement, the Paris Accord that they signed, and they were talking about cutting the greenhouse emissions. And they wanted to do that to keep the earth from heating up 1.5 degrees Celsius, which equates to 34.7 degrees Fahrenheit. So the COP goal is to get closer to fulfilling this promise in the 2021, that they made in 2021. We're still a long way away from that. But there are things that we all can do in cutting our energy consumption to help with that. And those are some of the things I'll be talking about this morning. The U.S. Department of Energy did a chart here this was back actually in 2008, and I looked at the newer chart. It's still kind of the same. We haven't reduced that much. But buildings take 39% of the energy consumption in the United States. Buildings alone consume that much, in 39% of it. That's a big chunk. 1/3 of it is a big chunk just for all the buildings that we have. And then they also, if you look, they did another study, and they were showing that most of the commercial buildings, about half of them were built in the U.S. before 1980. So half of the buildings that we see out there. Compared to the rest of the U.S., if you look at the chart, here we have, as it notes, the Northeast, Midwest, South. We're in the South. The green is us on the chart, and it's showing that our buildings, we've built more buildings in the South than the rest of the country. Kind of makes sense since we have so many people moving down to the South from the North. You need to have buildings for these individuals. You need to have houses. You need to expand your schools. You need to expand your universities. You need to do all these things to accommodate the influx of the population. So the graph showed that just through energy alone, it showed how much that the South has increased on that. And then the next study they did, it said, well, let's compare it to the global emissions of the world versus what the U.S. emissions are into the atmosphere. And we see the buildings take up 6% globally, and the U.S., we're at 6.5%. So we're just doing the same as the rest of the world, basically. So that's why those leaders came together and said we have to do something to control our emissions. Well, now that we know that a majority of the commercial buildings in the South were built before the 1980s, let's take a look at how they may relate to energy consumption. Just looking at the commercial sector alone that we see here on this graph, about 44% of the energy use is just used from HVAC equipment and HVAC cooling and heating alone, and ventilation. So you see you got your cooling, your ventilation, and you add the space, the heating. That chart kind of is from the north a little bit. We don't heat as much down here in the South, but we do a lot of cooling. So you could basically do it in reverse. So it takes quite a bit of energy consumption here in the U.S. And the last chart here, they're trying to get off fossil fuels. We talked about, if you look, not only did the world leaders come together, the American Institute of Architects got together, and they did their own challenge called the 2030 Challenge. And what that means, basically, they were trying to say, how can we try to get off fossil fuels by 2030? Well, we're only 8 years away from that, and that's not happening. But you have to have a goal to try to get to something. So that was their goal that they put forth, and try to get to carbon neutral. And I know a lot of K through 12 and higher education, especially in the new facilities that they're building, have done like LEED projects. They've done other sustainable Green Globes type projects where they're making the buildings more energy efficient by using better materials, Energy Star compliant materials, even as it relates to the rooftop. I see a lot of white roofing going on instead of just the darker roofing materials. So that has a higher solar reflectance, so it keeps your roof a little cooler and keeps your building cooler. So you're not utilizing a lot of your energy there. So there are numerous ways. So then, now we have a little bit of the history of why all of this is coming into play. What are we going to do? How can we help in this as building owners and facility owners? How can we help reduce our energy consumption? Well, there's some things that we have to look at. So, like I say, knowing that half of the consumption is, a third of the consumption is from the buildings, what can we do to our buildings? Well, some people say, well, let's just go and renovate them. That's true. You can do some things to your building to renovate, and we'll talk about some of those things here in a second. And some say, we'll go into new construction. We'll tear it down. You have to look at all these options. And that was when I mentioned earlier about K through 12. I've seen a lot of K through 12 school districts where their buildings were built in the 50s and 60s. Orange County Schools, just down the road there, they've torn down just about all of their old buildings except for the historic ones, and they built new campuses. New campuses. If you go down and look at that school district, you look on their website, they built new energy efficient buildings. Osceola County's doing the same thing. They're doing net zero buildings and high performance buildings. I said colleges and universities are doing the same thing. They're starting to build those high performance net zero. At Charlotte University of Florida, where they're doing buildings now where they're, I believe it's a public safety, and it's another one that we're doing as a high performance type building. So what's the reason for that? To reduce the energy consumption. And those buildings are going to cost much less to operate on the HVAC and the cooling and heating systems. So you have to ask yourself the question then, are you going to renovate? Or are you going to rebuild and do some new construction? Whichever the case may be, you need to start having the mindset of what can we do to reduce our energy consumption, whether we're renovating or whether we're building new. A lot of times that wasn't in there. We just wanted to go and build our building and make it look the most beautiful building there was, but it wasn't performing the way it needed to perform. One of those things, obviously, everybody knows about insulation. Insulation in your walls and in your roofing system and in different areas help to improve the thermal performance of your building. Reduces the need to have the AC as cold as it needs to be or have the heat as hot as it needs to be. Air vapor barrier, that's probably one of the largest things right there that's on the building envelope that can reduce your energy consumption. I did a presentation just on air and vapor barrier, and it has a slide. I wish I would have put it in here, but it has a 1 square inch. It shows like 1 square inch of air coming through your wall can produce 6 quarts of moisture. That's a lot. That's quite a bit. So you want to keep that air vapor out of your building envelope. You want to keep it sealed. You want to keep it monolithic and whole with no breaches in it. Looking at sustainable systems. You can look at your building, and there are some firms out there that does energy modeling. They'll take your building, do an energy model on it, see how your building's performing with the HVAC and over a period of time, and then you'll realize it'll show you that where your most expensive times are, and you probably already know that from your power bills, but your most expensive times and the least expensive times. And one other thing that I'd like to point out is you talk to your maintenance staff. Maintenance staff, that's where they're here for. They know everything about the buildings that they're maintaining. A lot of people don't really connect to them. When I go out and look at a site or something, I want to make sure I talk to the maintenance staff to see, have the occupants been complaining that it's too cold? Have they been complaining it's too hot at certain times? Have they smelled any unusual smells, the M word, the mold, or something like that? People smell those things. So you tap into that knowledge as well. Other sustainable systems, we talk about photovoltaics. All that is basically our solar panels. That's all that is. If you drive up and down the Panhandle that way, you go down south, you'll see tremendously large solar farms. They're out there all over the place. Go on Google Earth. They're all on there now. You can see them. Duke Energy, Florida Power, all those guys are investing in renewable energy using photovoltaics, and they're powering neighborhoods with this solar energy. They just put something out I just saw came into my mailbox. They're saying we can now have your house on renewable energy only. Just come and sign up. And I was like, oh man, that's pretty cool. I looked at it, but the price was just as much as if I was on the other energy source, if I was on fossil fuels. They haven't made it economical too much for us yet, but it's going to be there. You're going to get that flip-flop. That's why you see all of the electric cars out. I was really surprised that when I watched the Super Bowl this year, there was about 6 or 7 electric car commercials that were on during the Super Bowl. Every manufacturer is producing electric cars. When I bought my last car, I said, well, the prices were high. They weren't as high as they are now for gas, and I wish I had a full electric, but I have a hybrid. And in my hybrid, I'm decreasing my energy consumption and emissions into the atmosphere because I get 39 miles per gallon on my hybrid. So when the prices went up, I was like, okay, I got to go up a little bit, but I'm still ahead of the game. So you'll be ahead of the game in your energy consumption when you start doing some of the things that we're going to talk about as well. So what do you need to do first? First thing is we need to look at your building. You need to look at the building, have someone look at your building and find out what the issues are. That's a building condition survey. You look at it, you walk around the building. Again, your maintenance staff can help you tremendously on this. You walk around your building, you might see some openings. You might see some things that are not right. You might see a ceiling joint that's not right. You might see a window that's not closing properly. Even something as simple as that, those different things, and you start charting that information down. You start doing that survey to chart those things down. You look at your roofing system. Are you having any issues there? So you identify those things, and then remember I said you have to keep that same thought process of how I want to conserve my energy consumption. You start identifying things that you can do to conserve energy, and do some different measures that way. So when you do that, you start identifying any other phasing opportunities. Once you look at everything, we'll talk a little bit more, and then design construction phase. So you have to review the existing information. We talked about that enough already. And your field inspections, we talked on it briefly. And that can be visual or destructive. Most of the time you want to do visual. Unless you see something, then you can do some destructive testing, open it up, take a look at it, see what's the problem. And you can do testing. There's different types of testing that's out there. Infrared analysis, hydrothermal and type of testings. And I'll talk about that as well. And then you do all of those things that are at your disposal to test your envelope. And then you come down with a report, and you can have an analysis of these are some of the things that we need to do to improve our building performance and reduce the energy consumption. Now, I've said all these things, and you say, well, I can't remember all this stuff and the procedures that needs to happen. Well, ASTM has done it for me. ASTM, I'll just put these up here for those of you who like to go and see some of these things. These are 3 ASTM standards that direct you on how you can do an evaluation on your exterior envelope, okay? Now, according to the National Institute of Science and Technology, they did a study in 2005. I told you air barrier was very important, air vapor barrier. And there's many types of air vapor barriers that you can use on your envelope. But utilizing one can reduce air leakage 85%, up to 85%, maybe even more. It'll reduce your cooling. You'll get 26% savings in your cooling and 40% savings in your heat just by making sure your air barrier is tight and installed properly. Here's a typical wall component. Most of us have seen this. This is a kind of standard wall component. You have your CMU wall. And the reason I'm showing this is because you have we call it the perfect wall, and the CMU portion of it, it could be a stud backing, it could be concrete, it could be whatever. You have that wall. But what's most important after that is you have that air vapor barrier here. Then you have some insulation here. And this particular wall, you have the brick veneer, which is basically your rain screen, right, to protect everything else. So those are the most important components in each wall system. And if you don't have those, if you have a breach, especially, well, if you have a breach in your insulation, you're going to get more heat coming this way, obviously, right? If you have a breach in your air vapor barrier, it's going to get maybe absorbed, moisture might get absorbed into the masonry, or if it's a drywall and a stud type of thing, dense deck or something like that, it's going to get moisture in there. You're going to have delamination, you're going to have problems and issues. So, but those are the main components of the wall. So let's go back to that field evaluation as far as what you would do to look at your building. Obviously, a field measure up. You want to document those existing conditions, do any testing, and like I said, coordinate any type of sampling. Figure out the service repair history. You might want to, I document that all the time. Maintenance staff is very good at having that information. You document the service history. And what that kind of reveals to you sometimes too, and this is off the energy consumption just for a second, but what it reveals to you, you start getting your maintenance records and you start realizing, wow, we constantly have issues in room 210. Or we constantly have issues in the auditorium, or we constantly have issues there. So something's happening that's breaching your exterior envelope, and it's going to cost you more money to operate that particular room or that building. So it's a red flag for you. So then you can go in and you can investigate that and try to figure out what those issues are. And basically, this is just something I like to throw in there, just a little checklist I love checklists because no matter how young I was or how old I'm getting, I can't remember everything. So a checklist helps you remember all that stuff. Look, even something as simple as your doors. If you see all the different types that we show here, and your doors, are they hollow core doors? Are they solid wood doors? Are they metal doors? Do they have glass in them? Is it impact resistant type glass? Is it insulated? Sometimes just go by and touch the door and see if it's hot. Touch the glass, see if it's hot. And if it is, if it's pretty warm, you're bringing that heat into the space, and you're having to use more energy to cool that space. These are all those simple things. I say what we do is not rocket science. It's just maybe 10%, but most of it is just common sense type prevention. So, and one thing that we don't think about a lot is gaskets on your doors. You got double doors. You got air leakage coming straight through the building. A lot of times we'll go into a facility and you can hear the wind blowing. You can hear the air from the HVAC system just blowing in or blowing out. So if it's doing that, you're having to cool that and heat that. That's a lot. When we had the first cold spell, and it dropped down in the 30s, really cold for us, and I'm in Orlando area for us, it dropped down, and it was cold as heck, and the wind was just blowing as strong as could be, and Mr. Envelope guy who does everything right for everybody else, I feel cold air blowing in my front door. So my wife is kind of upset, and because we're running the heat, you can feel it just like I had the AC on, and I had the heat on at the same time. So I run to Home Depot, I grab some weather stripping, et cetera, put it around the door and seal everything up. And I kid you not, she noticed right away that we didn't have to run the AC. She started pulling the heat down a little bit more. But something that simple, it made a big effect on our energy consumption. It saved us time and money on that. So just me running to Home Depot. Those are some of the things you can do on your building just to make sure those things aren't happening that is causing you to use more and more energy in your facilities. What are some of the testing that can be done? Infrared, most of us know about the infrared thermography. One thing I always like to point out about the infrared thermography is it does not measure moisture. It measures heat, the differential of heat signature. That's what it does. Because moisture holds that heat a little longer, and that's what it measures. So that's why you'll see that those gradients, and we'll show you some images here. There are nuclear moisture meters, electronic field vector mapping. How many of you at your facilities have any type of green roof or garden roof? Raise your hand. One? Okay, two. So when they're putting those things down, you get one shot at it. You get one shot at getting it right before you put all the overburden and the grass and everything over top of it. And that's what electronic field vector mapping does for you. Before you put all that stuff down, you have two probes, and you put out like a 10 by 10 electric grid, and then they walk over the roof, and it'll point right to where you have an opening in your system before you cover all of that up. These are just moisture meters, air leakage testing, a lot of different things that are non-destructive. You don't have to tear anything open. Destructive, obviously, is test cuts, hazardous material. We put water infiltration testing as destructive because if you put it in there and it's leaking, you're going to damage something. So that's why that fell into that category. And then gravimetric analysis, testing all the different types of hazardous material, and things of that nature. And gravimetric analysis is basically just a wet dry. You take a sample of what you've had, you weigh it, and then you put it in an oven based on the ASTM standard. You dry it out, you weigh it again, and that'll let you know how much moisture you had in it. That's basically what that is. Now, hydrothermal analysis. This is something you can do. I'll let you in on a secret. If you like doing stuff like this and you like getting analytical and science techie stuff and doing software, this software, you can get a free version of this from Oak Ridge National Laboratory. But what it is, remember the wall system we showed you earlier? You can take any wall system, and it has data already entered into the program of all different types of material, because they've been doing this for a while. They've assembled all different types of material. You type in how your wall is built. Okay, I have CMU, I have this membrane air barrier, I have this insulation, I have this brick veneer. You put all that in here, and I live in, or my building is in such and such city, and you hit enter, and then it calculates over the course of the year in your location how your wall is going to perform. Simple. It tells you if you're going to have, if you have condensation, you're going to have condensation in your wall. Let's say you do have a breach and it's not designed right. It'll tell you in the winter, in between November and February, you're going to have the potential for condensation in your wall because you're heating here and this is what's happening. So that's what that program tells you. We like to try to have this run on existing buildings and obviously new construction when you're doing that, to make sure that you're not having any issues with it going down the line as designers. Back in the day, we used to have to do it by hand and try to remember all the products and everything, but now they've made it much easier for us. And it's at your disposal as well. Here's another one, thermal conductivity analysis. These are great for your windows. Right here, what is this? And this is also free too from Oak Ridge National Laboratories. So this program, Therm, basically lets you know, you say, I want to test my wall system right at my fenestration, at my window, and I want to see how my window itself is operating. So you put in the model. You can get that from the manufacturer. You get the model of the window, the type and everything, and you say, okay, we're going to run the calculation. And what it does, it looks just like the infrared, but you see how this is like in the wintertime because the heat's on, it's hot on the interior right now, and it's cold on the exterior. And you can see the way this window's designed, the cold only stays where it's supposed to stay. If it was coming through here like this, you know you had a breach. So it actually shows you in a visual a sense of a picture of how it's operating. And trust me, we've seen some. I wish I would have had one that showed you where it was actually breached and it came through and it was causing the owner to, again, use more energy because he had the leak in the window system. One owner came and said, hey, we got all these windows put in and we got a ton of condensation. What's going on? We did that, ran that on it. Sure enough, found out they were supposed to have what we call thermally broken windows, where you don't have where you have a break in the metal where it doesn't continue to keep that conduction of the heat or cool going through. They were supposed to have the thermally broken. And we did the model. The model showed you didn't have it. Then we went back and researched the documents. And sure enough, it was the wrong window. It was the wrong type of window. So it shows you all that stuff right up front. Oops, let me see if I can go back here. How to go back. Now, once you do all those things, you've looked at the building, you've done some testing, you've said, okay, we found out where all our breaches are, we found out what the issues are now. What do I need to do? Well, you got to talk to your boss or whoever it is, your upper management or personnel, and you got to give them something to substantiate what you're saying. So what he's going to want to know, he's going to know, okay, what's the condition of what you found? You're going to tell him that. You say, well, what caused it? Well, in your testing, you're going to find out what caused it, right? So, and then it says, what's the culpability of all of that happening, with all that happening and everything? How can we correct it? And the number one thing they're going to ask you is, how much is it going to cost us? That's the biggest factor. How much is it going to cost us? And then the next one is, well, how long is it going to take us to fix it, right? So those are the things that you want to know. And once you do that evaluation. So what should you consider then to reduce your energy consumption? One of the biggest things is to anticipate how long your organization plans on keeping that building. Higher education, you're keeping your buildings forever, basically. They're not going anywhere for a long time. So what's the anticipated duration? Will the building be occupied during the time you have to do the fixes? Is the building historic or significance? A lot of campuses have their historic sections of the campus, and you have to do certain things a different way as it relates to historic buildings. And then is the building going to be based off any type of sustainability system such as LEED or net zero or passive house? So you have to look at those things as well when you're considering. So what are some of the energy measures? I talked about Some people are putting photovoltaics up just to compensate for utilizing so much energy. White roofs that they're using a lot of, and it's basically, I believe the supply chain right now for those are much better than the other type of roofing systems, the modified bitumens and the asphalt type systems. So, last chart here is ASHRAE, and what they have done, they said, okay, there's an energy use intensity comparison. We want to compare basically of a certain building. Here's a building. It says here is the current facility's energy use intensity of around 207.5. They'll take your building and say, here's your building. Here's the national average is 199. So you're using a lot more. You do those repairs, you do those fixes, and then you find out what are we at afterwards. And this was done on a couple of facilities, and it shows you afterwards the consumption of energy usage went down just by doing minor repairs. You might say, some of you say, well, I'll just go up and replace my roof, and I'll just go and put new insulation up there because that has a lot of square footage. So I'm going to just replace my roof, and I know I'll cut down on my energy consumption. Remember I told you one of those biggest things that the upper higher management is going to ask you is cost. Roof replacement is not cheap. I know many of you know that right now. It's not cheap. So you look at this particular roof was $3.6 million. This was $3.5 million for the windows and then for the roof. And when it came down to the return on investment, yeah, they dropped their EU rating, energy usage, -13 for the windows and a -7. But look at the return on investment years. It didn't pay off. So that's why you don't just go in and make a blanket statement, well, I'll just do my roof. I'll do my roof when I have major problems or leaking issues and things of that nature that forces me to do that. Just don't go out and just say, I want to replace my roof to reduce my energy consumption. It's not going to be beneficial for you. And these are just some more examples of some of the ones that were out there. But you see it shot up in the high ranges for years of your return on investment. Energy conservation options. When you're doing that and you're working on your project, like I say, whether it's going to be phased or it's going to be occupied, you got to develop a long-term facility plan to make all of these things happen, because it's not going to happen overnight, obviously. It's going to take some time to go from building to building and do what needs to be done. And the time frame to do that is going to be important. Is it immediate? Is it short term? Is it immediate term or long term that your fix needs to happen? Obviously, if you just got windows that are leaking like a sieve, that's immediate. You need to do something to address that. This particular chart just kind of shows the same thing that I just told you here shortly. You know, the short term, immediate, long term, etc. And it just does and these are just for roofs basically. Just gives you an idea of when you do some repairs. When do you have to replace it? It's going to be short term, and those are programs that are out there to help you do that. And I wanted to show this one because a picture's worth 1,000 words. Once you've had an analysis done and you've done those things on the different buildings and finding out if you have any issues related to getting all this air and moisture and vapor inside your buildings, you just kind of do a little color chart. This is a campus where you did a little color chart. Red is poor quality. The green is high quality, so your superiors can see right away, well, we can address these on a phased approach, and you have to put them on a scale of, worst case scenario versus not so bad as well, but at least it gives you an idea of how that's mapped out, what needs to be replaced. So we can review the construction projects. You can, if you're doing a capital program, you review those projects and say, hey, we want to include this, the repairs in our capital improvement plan. And whether it's, like I say, immediate or long term, you can fit those issues in there a lot easier now that you know what they are. You're not shooting and throwing darts at the wall. You figured out what you're going to need to do, and you can plan for it. And you compare it against the plan for a new building, like I said, or you can incorporate some energy upgrades. such as insulation, such as the vapor barrier, such as resealing around your windows, such as resealing around the doors. Now let's look at a quick little case study here. This particular building was phased construction. It was a full occupancy at the time. The thermal value was increased, new windows were installed, and it was on the Energy Star program. Now, what the Energy Star program is, they give you a rating of 0 to 100. And say, for instance, your building's at a 60, right? They've rated you and you're in that program. Well, you said, okay, well, I want my rating to be a little higher. I'm going to go and do some things to reduce my energy consumption. So you go in, you put a few new windows in, or you've sealed up your envelope, your exterior, and you're not using as much. And you jumped up to a 75. And you go, oh, great, I jumped up. My rating's a 75 now. Well, they compare that to other buildings very similar to yours. So what they'll do, they say, okay, school A, owner A, is at 75 with this type of building. Well, owner B just went and did some improvements. Now he's up to 80, 84. So it just pushed you back down. And you go, wow, my same building is not meeting it now. So what they've done that, the reason they do that is to make the owners keep competing against each other to make sure their buildings are efficient, right? You want to try to get to 100 as best you can. Now in this case scenario, this particular one, like I said, was fully occupied, and it had new improved windows, and thermal values were changed because of the insulation on the walls. I told you it was a part of the Energy Star program. As your building ages, and then, like I said, the new building gets constructed, your rating goes down. Now in this one, this was a metal frame construction. This is an infrared image showing the wall system. You can see the metal studs. And I told you it doesn't measure moisture, it measures heat, right? So this bright part here is the heat from the metal studs. You're seeing how much the metal studs are radiating heat within the wall system. And you can see there's some insulation in between, some of it's falling down, but then when you look here, something significantly is happening at the floor level. There's a big problem going on at the floor level. And you can see a little bit going around the window. Some of this is just splash out from that. But you can see this is an indication of moisture intrusion around the base of the windows, and then something's going on there because it's that heat signature. And you can see here that around the cornice in the attic, a lot of heat is going on. Something's going on there. So the infrared tells you have a problem. So with destructive testing that was going on, once that cornice was cut open, you could actually look down the wall and see inside the building. So it was losing all of that heat and everything and going back and forth from the attic to the interior of the building. It was all open, and it was getting to the windows and everything, and that's what occurred when they took some of the siding off. It was all damaged because the moisture and the heat and the vapor and all that was happening, getting into the building, and it ruined the wall exterior, the wall stuff below the cladding. So all of that pointed out just from the infrared, just from looking at infrared alone. So there was obviously no need to do any leak testing when you saw that. Now, what was some of the things that the owner decided to do? He says, okay, my building is actually sick and I'm using so much energy because of all these openings. They actually went through, took the cladding off, put on a new vapor barrier around on the wall system, put on new substrate as well, obviously. New vapor barrier, insulation where it was needed, where it was damaged, and just replace whatever was damaged, put new insulation there. And what was so unique about this one, I said it was occupied, is what happened was the contractor came in and says, okay, I know I have to take out these windows, but this building is occupied. He would come in early in the morning, take out about 2 or 3 windows in a certain area, and put the wood framing for the new windows to go in, and he waterproof it and everything, put the vapor and waterproofing membrane in there, and then he put the windows back in. And by 10 a.m., the workers, the building occupants could come in and they can go back and work in their office. That's a part of phasing and staging. But, and in the end, they ended up putting the rescanning on that, and it saved, their bill went down tremendously as it relates to their energy consumption. So you're able to use those dollars other places now instead of just on, maintenance repairs. On that insulation that I was telling you about, it was supposed to be an R13 around there. Because you saw the metal studs, it broke up the flow of the insulation. It was a breach, a thermal break. And because the insulation wasn't continuous, it reduced the R value to a 6. It's supposed to be a 13. So over half, it reduced the R value of the wall system, which means what? If your R value is not there, it shows you how much you're going to be able to, how your wall's performing as far as thermally. The higher the R value, the better. So the R value got cut in half because of the metal studs. So in the repair, what they came and did, we kept the insulation within there, put a 2-inch continuous over the studs, and then put the drywall on. And then it jumped back up to where we're supposed to be according to code. They're not using much energy anymore. Something as simple as that. That was obviously these are worst case scenarios. Everybody's not going to reclad their entire buildings all the time. But we just wanted to do these to show you how impactful making these type of changes can be. So here's another one. This was a full renovation. It was not occupied, this particular one. There are some times where campuses say, hey, we're going to use this building for something else. Nobody's in it, so let's renovate it, let's use it for something else. Then you put your mindset on and say, hey, if we're going to do that, let's make sure the building envelope we can improve the performance of this building while we're doing that. That's the case of this particular project. So they came in, there's that infrared again, you're doing an image on it, and found out you got problems around the headers of the windows, wall leaking in between them, and you can see the studs there. The studs are cool in this one, but in between there's no insulation. That's why it's showing a hot signature. There's no insulation between the studs. So they came in and said, what can we do? And this was so unique where they came in and says, okay, this is a concrete structure. What can we do? We just put some insulation on the back sides of the concrete panels. And they came in and spray foamed. Everybody's familiar with spray foam. They came in and actually put spuff on the back walls of the concrete walls. And you can see the spuff, the green spuff between the studs and everything. And the neat thing about spuff is it expands. So if you had any type of gap behind the stud, the spray is going to seal that gap up. So it makes it that monolithic insulation. So that's what they did on that one. And there was a area here that had like a little concrete knee wall. They weren't using a lot of these areas as the balcony and the outside areas. So the owner said, well, I want to increase my square footage. So they took those out and pushed the wall out and put some curtain wall in there, thermally efficient curtain wall, and it expanded the square footage of the space and gave some more daylighting. Last one, exterior recladding. This was full occupancy as well. And some of you have dormitories that looks very similar to this. This was an apartment complex very similar to that. And this is, again, worst case scenario. They were having issues with air infiltration. And you see these little HVAC units. Those are notorious for letting air through the wall. So, and then you have the balconies and just everything was happening. You see the old type windows and everything that were in there, single pane, not thermally efficient. So this particular owner wanted to keep this facility, and he's renting all these things out. He went full force, replaced all of the windows, replaced every single window. And you can see some of the images where the new windows now, the cladding, that's the air barriers they put on the open areas, put a little glazing back over here to give it a little aesthetic look. And that's just a close-up of how they were tying in all of the different components to make sure that nothing was getting through. And then you can see the rock wool insulation that they put on those areas that didn't have any windows. This owner was very serious about, hey, I don't want to spend a lot of money on electricity and my energy. And it came out, and that was the end result, and turned out to be a great project, and for the owner as well on his savings. So it's a lot we could go into on this in super detail. So I tried to keep it as simple as possible. I was always told when I speak, keep it simple, stupid. So I tried to keep it as simple as possible. But I'll open it up for any questions that you might have. Do any of you get an opportunity to, you probably don't in the higher education, but it'd be interesting to find out what you're spending in certain buildings, what your energy costs are. That's some things you probably you should ask your superiors, I would think. Say, hey, what is our average such and such for maintaining this building on our energy? Because and then you might say, okay, now let's do this. We're going to be doing some repairs over here, et cetera, et cetera. Now, in about a month or two, once we've done the repairs, can you tell me what we're spending on this? And just do your own little test case and see if it reduces anything. And if you start doing that, man, you're going to be golden. The reason I say you're going to be golden because you're going to be showing them data that says, hey, look, we did these things to our envelope or to our facility, and we're not consuming as much energy on these buildings. And now, when it's time to come and get funding and different things to do something, it's going to be a lot easier for you to get that because you've proven that it's important to maintain that building envelope. Yes, sir. Mm-hmm.
My question is, should the architect or the MEP design firm be the one that would be really knowledgeable on this thermal equation and that balance? What's your experience with that?
I've worked with a ton of MEPs. They would be more knowledgeable than an architect. I can tell you that right now. So I would consult with them as well. The architect's going to be driving for us, obviously. That's a good question. That's a good question. Quick story. I know we're probably over time, but there was an architect that I had to work with. This is a personal story, and they were called one of the what they call up in New York the FLAPPA, one of like the 5 biggest architects in the country. And they came down. I was doing work at Disney. They were doing all this Disney stuff, and came out. Many of you may have seen Coronado Springs Resorts. That's what they were designing. And Disney said, we want to have a building envelope consultant on board with you guys to help you do this stuff down here. And they were like, what do you mean? There's no way in heck we need to have anybody telling us what to do, directing us. That was the attitude. So as the project progressed and we started doing things, they started saying, well, you're going to take care of that? You're going to take care of that? You're going to show me how you're doing that? We became best buds because they realized the value of utilizing that other source. I was always told, if you want to be great, you need to have great people around you, right? Right? I can't do everything. You got to have other people that are good at what they do around you. And the architect started understanding that. And that's what this thing we do called commissioning. Architects went against that at first. Mechanical engineers went against that at first. And then all of a sudden, everybody's working together now because they see the value in doing that together and making the best product for the owner. So that's my little quick story. I think you just pursue it, and I think they'll get on board. You did? Okay. Yeah, that's what'll happen. They'll realize the value in it, and they'll say, well, we're all in the same team, trying to get the owner the best product and the best building he can have. That's what's important. Giving the owner a building that he doesn't have to come back to. That's what's important. And they're able to maintain it efficiently. Any other questions? Well, I thank you very much for attending, and I really appreciate it.